This lesson video is for section 4.9 quadratic systems. Our goals or objectives for this lesson are that we can solve and graph systems of linear and quadratic equations, as well as we can solve and graph systems of quadratic inequalities. So let's recall what solutions of a system are. They are the points where the graphs of the equations intersect. So when you are working with a linear quadratic system, that means you have one linear equation and one quadratic equation. There are three possibilities. You can have two intersection points as shown in the first picture. You could have one intersection point as shown in the middle picture, or you could have no intersection points as shown in the last picture. And for those three situations, the solutions would be either two solutions, one solution, or no solutions. In example 1, we're going to solve a linear quadratic system by graphing. So we're given the system y equals negative x squared plus 5x plus 6, and y equals x plus 6. So as you can see, we have a quadratic equation for the first one and a linear equation for the second one. What we want to do is plot the linear equation by using the slope-intercept process. So start at 6 and go up 1 over 1. And then for the quadratic, we're going to graph as in the previous couple sections, actually in the beginning of chapter 4. Find the vertex and then choose a couple other points close to the vertex and make a table. So that's our process that we're about to start. Here's our graph of the equation y equals x plus 6, as we just talked about. Now I'm going to walk you through the process that we have learned in the past, earlier in chapter 4. To find the vertex, you want to find x equals negative b over 2a. That will give us the axis of symmetry, and then from there we're going to plug in that value to find the y. When substituting in 5 for b and negative 1 for a, I get the equation for the axis of symmetry being x equals 2.5. So that means our axis of symmetry is at 2.5. So I know that half of my parabola will be on the right side of that axis and the other half on the left side of that axis. Now to find the y coordinate, we're going to take 2.5 and substitute it in for x in the original quadratic. When we simplify that, we get 12.25. That means our vertex coordinate is at the coordinate 2.5, comma 12.25. So now let's plot that. Making an XY table will help us find a couple other points on this parabola. So you can choose about 2 or 3 points to the left of the axis of symmetry or 2 or 3 points to the right. And I usually choose the easier numbers to plug in. So 0, 1, and 2 would be the easier numbers to plug in. So now make yourself a little XY chart like I did. And then to figure out the Y values, you just need to substitute each of these X values in for the original equation. So when you plug in 0, you get positive 6. When you plug in 1, you get positive 10, and when you plug in 2, you get positive 12. So now let's plot those 3 points and then reflect across the axis. For the reflecting process, remember you just need to count how many units horizontally are each of those points from the axis of symmetry. So checking this point out here, it looks like we are 0.5 away, so that means you just need to count 0.5 to the other side. This point is 1.5 units away, so count 1.5 to the other side. And this point is 2.5 units away horizontally, so count 2.5 units to the right. And connect. So as you can see in the graph, we have two intersection points of this system. The first coordinate point for the intersection is 0, 6, and the second coordinate point is 4, 10. So these are the two solutions of the system. As you know, graphing by hand is sometimes hard to be accurate. You can always use your graphing calculator to ensure that you're doing the right thing. Another way that you could check your answers is by plugging in each of your answers back in for both equations that you're starting with in the system. Remember, when you have a solution or an intersection point, that means the coordinates are solutions of both equations. So that means when you plug in the coordinates back in, you should get the same answer on both sides. In example 2, we're given a system of equations. Again, it's a linear quadratic system, but this time instead of graphing, we're going to be using substitution to solve. And this is the same kind of substitution that we practiced back in a previous chapter when we were working with a system of linear equations. So because both of the equations are equal to y, we can set them equal to each other. So that means we have the equation x plus 3 equals negative x squared minus x plus 6. What we want to do now is write this in standard form, which means we want to have biggest exponent to smallest, and we want to have 0 on one side of the equation. So the way that I'm going to do that is I'm going to add x squared to the other side, because we want to have a positive leading coefficient. So that means we get x squared plus x plus 3 is equal to negative x plus 6. Add 1x to both sides. And that means we have x squared plus 2x plus 3 equals 6. And now subtract 6 from both sides. So we have x squared plus 2x minus 3 is equal to 0. Because the a value in front of the x squared is a positive 1, and the numbers for b and c work out well for the factoring process, we can factor. If this was not factorable, you could always use the quadratic formula that we talked about in a previous lesson. So using the x method, you take the last number, put it up top, take the middle number, put it on bottom. Think to yourself, what two numbers do you multiply to give you negative 3, but when you add those same two numbers, you get positive 2? The numbers that work for this situation are 3 and negative 1, because when you multiply those you get negative 3, and when you add those you get positive 2. So now we want to write that in factored form, so that would be x plus 3 times x minus 1 equals 0. Because the product equals 0, that means one of the factors is equal to 0. So we want to set both pieces equal to 0, and then do one step to solve each part. So for the first equation, we have x plus 3 equals 0, so you want to subtract 3 to the other side. So we get x equals negative 3. And then for the second equation, x minus 1 equals 0, you want to add 1 to both sides, so you get x equals positive 1. So these are the x coordinates of the two intersection points. Now to find the y coordinates, we want to take each of the x values and separately plug them in to either equation to find the y values. And hopefully you're realizing that the linear equation would be the easier one to work with, so that's what we're about to do. So using the equation y equals x plus 3 and substituting in our first x coordinate of negative 3, I have y equals negative 3 plus 3, which equals 0. So that means our first intersection point is at the coordinate point negative 3 comma 0. When x is equal to positive 1, we're going to use the same linear equation. Y equals 1 plus 3, which equals 4. So that means our other solution or intersection point is at the coordinate point 1 comma 4. So these are the two solutions for this system, this linear quadratic system. As always, you can check your answer by either graphing in your graphing calculator or by substituting both of these solutions back in for the system and making sure that they work for both equations. In example 3, we're going to learn how to solve a system that has both quadratic equations. And the good news is we can solve quadratic systems using the same methods that we have used for linear quadratic systems. We need to find the solution of the system y equals negative x squared minus x plus 12 and y equals x squared plus 7x plus 12. The good thing about this is that both of them are a standard form already, so that means both equal y, which means we can set them equal to each other. So as you can see, I wrote them equal to each other, and I put ones in front of the variables that did not have a coefficient. So now what we want to do is just play a game of combining like terms. So first thing I'm going to do is combine the x squared. So I want to add 1x to both sides. So that means I get 2x squared plus 7x plus 12 equals negative 1x plus 12. Now I want to add 1x to both sides. The whole goal is to get 0 on one side. So now we have 2x squared plus 8x plus 12 equals 12. And now we want to subtract 12 from both sides. So we get 2x squared plus 8x equals 0. Now, taking a look at both terms, I notice that there is a GCF because both of them are even, 2 and 8, and we also have an x in each. So that means the GCF is 2x. So as always, we factor out the GCF, we put it in front, and then whatever we need to multiply by to get the original. So that means we need to multiply by x plus 4. So that is the factored form. From there, to find our x values, we need to set both of them equal to 0. So 2x equals 0 or x plus 4 equals 0. and then divide by 2 for the first equation, so we get x equals 0, and then subtract 4 from both sides for the second equation, so we get x equals -4. So we just found the x coordinates of both of the intersection points. Now to find the y values, you need to pick one of the equations that we started with and substitute each of the x values in separately to find the corresponding y. Out of the two equations, I would prefer to work with the positive coefficients. So I'm going to use the equation y equals x squared plus 7x plus 12. When substituting in 0 for the quadratic equation that I just talked about, I get a y value of positive 12. So that means my first intersection point is at the coordinate 0, 12. Now I'm going to plug in -4 for the x and see what we get. So we have positive 16, -28, and plus 12. And when I add and subtract there, I get 0. So that means my other intersection point is at the coordinate point -4, 0. So those would be the solutions. Now I'm going to show you the process of graphing these equations in the graphing calculator and using the intersect feature to find the points of intersection. So pull out your graphing calculator if you don't have it out yet, turn it on and go to y equals. Now take a moment and plug in or substitute in both of the equations that were given. So now that we have the equations entered, we want to go to trace. As you can see, the parabolas are intersecting at 2 points. So now we want to figure out what those points are. So using the intersect feature, we're about to find the intersection points. So go to Second Calc and down to Intersect. And then it's automatically going to choose the first curve and the second curve. And it gave us our first intersection point of 0, 12. So that confirms our algebraic work on the left side. To get the other point, we're going to go back to Second Calc and use the same feature, intersect. And now you just need to arrow over so that you are closer to the other intersection point. Press enter, and then it automatically jumps up to the other curve. Press enter, and one more time, and it gives us the other intersection point of -4, 0. So here's a summary of what we just did. So just in case you need to catch up, it's here for you to look at. So one more time, the solutions of this system are -4, 0 and 0, 12. Hopefully the 0, 12 makes sense to you because they both had y-intercepts of positive 12. Be prepared to use both methods, substitution and the graphing process. In our last example, we're going to practice how to solve a quadratic system of inequalities by graphing. So what we want to do is graph each inequality and find the region where the graphs overlap. When substituting in the values for a and b, I got my axis of symmetry equation to be x equals -4.5. To get the y-coordinate of the vertex, I substitute that -4.5 in for the x in for both parts of the given quadratic. So I found out that my vertex is at the coordinate -4.5, 18.5, and I plotted that here. And to find a couple other points, I just chose values of x that were close to -4.5. So I chose -3, -2, -1, and 0. And to figure out the corresponding y values, I just plugged in each of the x's in for the original quadratic. From there, we're going to graph those and then reflect to the other side. Because the inequality symbol is less than, that means our boundary line is dashed and we're going to be shading below. So for our second inequality, we have y is greater than x squared minus 2. You may have noticed when you were looking at this that the b value is not there because the x term is missing. So that means b is equal to 0. So when we find our axis of symmetry, we have x equals -b over 2a. We have 0, technically -0, but that's the same thing as 0, over 2, which is equal to 0. So that means the axis of symmetry is on the y-axis. Plugging in the x value of 0 back in for the equation, we have y equals 0 squared minus 2, which is equal to -2. So that means our vertex is at the coordinate point 0, -2. So we can plot that now. Now let's make a little xy table just like we did in the first quadratic. And this time I'm going to choose x values of 1, 2, 3, and 4. So when substituting in 1, you have 1 squared minus 2, which is equal to -1, Plugging in 2, 2 squared minus 2, 4 minus 2 is 2. 3 is going in, 3 squared is 9, 9 minus 2 is 7. And 4 is going in, 4 squared minus 2 is 16 minus 2, which is 14. So now let's plot those points and reflect. The inequality symbol that we were given in the beginning was greater than, so that means we have a dashed boundary line and we're going to be shading above. The solution of the system is the region where the graphs overlap, and I highlighted it in yellow to make it obvious. The region contains no boundary points because we had dashed boundary lines, so that means the points on those boundaries are not solutions of the system of inequalities. So now you have seen a graph and a substitution problem dealing with a linear quadratic system. We also use substitution and graphing for a system of quadratic equations. And lastly, we worked with a system of quadratic inequalities. So that completes this lesson. Here are today's lessons check problems. I am requiring you to do numbers 2, 3, and 4, so make sure you write those down and show your work, including the graph for number 4. If you'd like some extra practice, I recommend doing numbers 1 and 5 as well. I hope this lesson video was beneficial for you, and I will see you soon, and this completes Chapter 4.